Hello everyone. Many of us might be using Azure Databricks or Databricks in AWS these days. And all of you know, in your cloud bill, if you look at one of the major contributor in your cloud bill is from Azure Databricks, right? Now, if you go to the cost management page, especially I have seen in Azure, it's very difficult to get detailed cost drill down under Azure Databricks Workspace for individual clusters. Let's say you have one Azure Databricks Workspace, and in that workspace, you have multiple clusters. And those clusters are being used for running your compute workload. It could be an interactive notebook, it could be a workflow job, it could be a scheduled job. All of them would require compute resources. And in Azure Databricks, you get them through the cluster. There are two different kinds of cluster that you can get in Azure Databricks Workspace. One of them that you create from the UI of the Databricks page, which is more of a persistent cluster, pre-created, right? And you can define your SKU type, how many of worker nodes that you require, minimum and maximum in the cluster, and then you can define the configuration for the driver node, right? So that is on the that is something you create on the UI. The other kind of clusters that you can create is when you schedule a job in Databricks, you can say, it will bring up an ephemeral cluster, right? The cluster will come up on the fly. It is not an interactive cluster or something that you have already pre-created from the UI. Right? Now, those are the two kinds of cluster which can take your compute workload. However, uh, why I'm interested to see the cost drill down under a particular Databricks workspace is in Azure cost management. You can get the overall cost at the Databricks workspace level. However, if you want to see a drill down of the cost, like under that workspace, if there are 10 clusters, which cluster is contributing how much cost, at least some ratio. Let's say if I'm spending $100 for the overall Databricks workspace, that $100, is it coming $10 each from the individual clusters, or only one of them is contributing, let's say $90, and rest of the uh, nine remaining clusters are contributing only $9, right? So you will be interested to see which cluster is consuming how much resources, or more than that, how much cost is incurring to the overall Databricks workspace cost. That is the objective. Let me share my screen. It might take a couple of videos to reach to the final objective. However, we'll start working bit by bit to reach towards that overall objective. In my screen, you can see the repository that I have created for this is Cloud Infra Cost, and under that, I've created a specific folder for Databricks. And then, because it will be going through some iteration, I've created chapter 1, CH1. So you can go to chapter 1 and look through the code that I have created for today's session, today's video. I will follow through the steps that I have shared in the README page for Databricks. Again, I'll reiterate the objectives. We'll find out in a Databricks workspace details about all Databricks clusters available and the different kind of clusters that I've already mentioned, like UI or interactive. And the second one is job or ephemeral under Databricks workspace. Details of all jobs scheduled, their name, their schedule details, etc. And then correlating information between clusters and jobs to find out which jobs are running against which clusters. So in today's session, we'll be covering only this much. And in the subsequent session, we will enrich that code more and more. And finally, we'll hopefully be able to create some visualization. I'm thinking I'll use Apache Superset towards the end. But today's video, it's mostly I'm going to cover how you get all these details and then presenting that information from within terminal itself. Right? There are a few steps that will follow before we can run that code, right? Sample code, and I'll take you through the code also, line by line. First thing is you need to capture these two information, and we'll set them as environment variable. First one is Databricks host, and if you are using Databricks in Azure, then the URL format would look something like this: https:// in this place you'll have the primary part of the URL, then we'll have the suffix azuredatabase.net, and then in that workspace you should create one Databricks token so that you can use that token to authenticate yourself to make use of that cluster, the workspace programmatically, right? From in our case, we'll be using Python to interact with the Databricks workspace and clusters, right? Those are two things that you'll have to get from your Databricks instance, and then you'll have to set them in the terminal. I'll show you that how you set that. Then step 2 would be explore the Databricks APIs. Okay, and today for the today's session, we'll be focusing primarily on the clusters, jobs, and runs API from Databricks. Databricks has REST API, and will be in fact using Python SDK for interacting with Databricks. I'll show you the modules, external modules that you'll have to install in the virtual environment. There are a few references that you can look through. I've kept them open. Databricks, the first one is Databricks CLI, second one is API, and the third one is the documentation. Okay, let's go through them quickly. Databricks CLI is the primary one that I'll be using, and then you can get that same thing be done using Databricks API as well. Also, some of the API calls using Databricks API library. The core REST APIs which are from Databricks, they no matter whether you are using Databricks CLI or Databricks API, and under the hood they will call the corresponding REST APIs from Databricks. And this is the page for that. Like for example, for listing down all the clusters, this is the REST endpoint. So you can go through these details at your convenience. Now let's go to the code and check it out. So you can clone this repository to your local system, and then that's what I have done. So you can see database clusters, clusters events, all those files are present here as well. Okay, let's go one by one. So the first objective is listing down all the clusters, and invocation is going to be pretty simple. I'm using Databricks CLI for this purpose. You can use Databricks API as well. The constructs are going to be more or less, very similar. So first you import the required libraries. In this case, I'm going to invoke clusters API. So cli.clusters.api, import cluster API, and then I need an API client. The two environment variables that I told, either you can set it here in the code or you can set it in the terminal itself, right? This terminal I set. Now, one thing that I have done is I have created a fresh virtual environment for this. You just select this and then go to preferences. And then for, in this case, your project is cloud infra, so select that specific root configuration location here and click on the Python interpreter. Okay, here, if you click on this add, and then select a virtual environment and then say OK. For my case, I've already created a virtual environment, so I'll skip that. Once this virtual environment is set, based on the requirements.txt, you might get a prompt like, so and so libraries are not installed. So there are multiple ways you can install these libraries. You can go to Python packages and type in that library name or module name here. Let's do that. Again, in my case, it is already installed. And see that in your case, it will let you select that, and on the right side you'll have it. The install option will be available, right? If I delete it now, next time you can see that install option will come back. Okay, let me show that quickly. Maybe just for one library, Database API, I'll show you. Rest of the two libraries are already installed. You can follow the same steps like you're following the Databricks API. Okay, okay, it takes a while. Right now I'm just uninstalling the package and I'll reinstall it. Okay, now you can see, yeah, let it reload and refresh. Okay, so Databricks API. Okay, if you see here, there you go. You can see right now it is not installed, so you get the install option enabled. Just select that, but click on that button. It will install the package within your virtual environment. Right? As it installs, let me take you through the code. First, I'm creating an API client using the host and the token that we have set here. So I'm saying host equals to os.getEnv. The value that I have set against this variable, it will be replaced with, and token equals to that. This second one, once the API client object is created, I want to pass that into the cluster API object initialization, and now I have got a clusters API object. I can then start making calls which are available under the clusters API. You can see what all methods are available. Get events, get cluster, start cluster, create cluster, delete cluster, edit cluster. Many of the core functionality that you get even from the Databricks user interface. In this case, I'm just going to list down all the clusters. This API call is sufficient, list underscore clusters. Once I've got the list, I'm going to navigate through and print them. And then I'm also adding all the cluster IDs into a list, and then I'll print the length of like how many clusters I have in this workspace at the end. So now it is about to finish the Databricks CLI. In fact, it is just finished. So now if I go to terminal, and by the way, I have set these two environment variables already here. You can just say export Databricks host equals to within double quote or single quote. You have to put the your corresponding Databricks URL here. Okay. I'll have already set. I don't need to set that again. In same way, you just set the other variable, like export Databricks token underscore token equals to the token value. Once that is done, you can come to the terminal and say Python, the Python file name. So now it is listing down all the clusters, and the response that you are getting is a JSON response. We'll look through some of the cluster details. Yeah, there are total clusters, 20 clusters available, and for each of those clusters, you can see the details here. Yeah. So this one, remember I told there are two kinds of clusters. One is job cluster, which brings up the cluster when the job is actually triggered as per the job schedule. Or if you say, schedule now, basically you are triggering now. So when the job is getting triggered, the cluster will also come up first, and then the actual job code will be run in that cluster. Right? So this is job cluster source. Likewise, you'll see for some of the clusters, it is marked as UI. That means the cluster was created on the UI itself manually, and that cluster exists uh, even before the job in the cluster is run, right? So you are pre-creating the cluster. Then when you are creating a job, you can mark that job should be run in that particular existing cluster or a new cluster. If it is existing cluster, persistent cluster, that will be cluster source as UI. And if something is coming up with the job, that will be marked as job cluster. Okay? All right, so you can see lot many details here, starting from here. Auto skill, max workers 16, mean workers 4. That is the driver, the worker node. So you'll have when the cluster is started for started at any time, the minimum number of worker nodes it will have is 4, and the maximum number of worker nodes it can reach up to is 16. Auto termination minutes is like if the cluster is idle and there are no jobs running. If it is idle for 10 minutes, then the cluster will get automatically terminated to save any cost, right? So you don't want your cluster to be running 24/7, even if there are no jobs running in that cluster, right? That's not the good optimized use of your cluster. Sometimes you might see it is like very, very high value, 30, 60, 90, unless there are some genuine reason as to why you should keep your cluster idle for so long. You I personally would say have these auto termination minutes as much smaller as possible, right, to save the cost. There can be one genuine reason that I can give you right now. There can be a few more, but one genuine reason could be, let's say you are running multiple smaller jobs in continuation with some small gaps in between, right? As the first job takes 10 minutes and there is a break of 2 minutes, and then the second job would run and it would take again 10 to 20 whatever time it takes. So if you keep your auto termination on, it may happen that uh, the cluster bootstrap time, right? So when you bring up the cluster, there are some initial overhead that is required. You'll have to procure the compute that is defined for that cluster, right? And then you have to start spinning up those VMs, and then you have to bring up the Spark related services there, right? The Spark cluster has to be set up. Once that is done, then you can actually start running your job. So the initial overhead is going to consume a lot of time. If you want to avoid that and you have jobs being run in continuation one after the another with some little gap, in that case you might prefer probably not to terminate your auto terminate your cluster. But in 90% of the cases, you will find auto termination is very, very useful feature. The other things is if you want to use spot VMs, right? That would also cost you little lesser than the regular VMs, right? Cluster ID and few other cluster name. Now these information I have obfuscated. I don't want to show the real cluster name, cluster ID, or cluster username. So those information what you see in the screen, they are obfuscated. Okay. So this is one kind of cluster. You can see the Spark version. You can see lot many other information like the node type ID, that is the VM's queue type. In this case, it is standard E16 as V3. When was the last restart time? When is the node type ID, runtime engine standard, and you can have premium. All right. Current state is terminated. So this cluster is currently in terminated state. It is not running. And you can see the reason also, state message, inactive cluster terminated. So the last time this cluster got terminated, it's due to that inactive threshold that you have set, auto termination. All right. Then we can look through another cluster that is of type job, cluster source as job. And this cluster, by its name also you can make out, this is a random job cluster name. That means whenever the corresponding job is triggered, either manually or based on its schedule, it will bring up a cluster on the fly. However, it might have defined the cluster definition, like how many worker nodes and all, that you might have already defined here. Number of workers and node type ID, right? So there is no min and max. It is like number of workers that you have set in the job cluster. Okay, so we have listed down all the clusters here, and then finally I'm just looking at the length of the list, and in this case there are 20 individual clusters which are available. Similarly, I'll take you through the jobs list also. Again, this is mostly on the same line. In this case, instead of cluster API, sorry, I'm using jobs API. Okay? And the second part, probably I'll go separately. Like first, you list down the jobs and go through the jobs definition, those meta information, and then you also want to see the run details for this job, right? If the job has been run multiple times, you want to see the details from the previous runs also, right? In that case, I'll be using runs API. Cron descriptor, probably in this file I'm not using, but I'll explain the usage of cron descriptor is like when you schedule a job that is a cron schedule expression. It is not easy to interpret, right? Unless you are a techie, it will be difficult to interpret that schedule in the cron expression. So I'm using this cron descriptor library that will actually help you to interpret that cron schedule, uh, which is very cryptic to something human readable, and it's more intuitive. I'll show you as an example when it comes. So in this case, I'm just using the jobs API and calling the list jobs under the jobs API. That's it. I'll not go through this in details. You can go through. Uh, and then, as I said, if you want to see the runs details also, how many times the job has been run, and details about that. Let's see that quickly. So Python Databricks jobs. And I have obfuscated the information, but it will be it will be good. I'll take you through explaining one of the jobs definition. So the result that you see towards the end is from a job run. Before that, I want to show you the job schedule. Look at this particular one. Create a username, job ID, settings, email notification for different kind of alerts like on success, on start, on failure, no alert for skipped runs, existing cluster ID. So that means this job is going to be run in an existing cluster, which is of type UI, right? If you see new underscore cluster, in that case, that job is to be run not against any persistent cluster, but a job cluster, an ephemeral cluster, which will spin up during the job, during the time when the job gets triggered. And you can see all the details, like the name of the job, what is the schedule, current status is unpaused. That means it is not paused, it will run as per the schedule. This is, as the cron expression is not human readable. I'll show you by using cron descriptor how it becomes more intuitive. The Spark Python task, the Python file that you are running, any parameters that you need to pass to that job, right? All those details are captured here. Okay. So that's about the job details. And if you want to see the run history of a job, in this case, I'm getting the runs for a particular job ID, which is 18. And we'll list all the runs for that particular job. All right. Yeah. You can see from where it might have started. Let me take you to the beginning of the place from where you're seeing the jobs run history. Okay. And for every single, these are all those run instances, and there is a run page URL. So if you click on this, it will take you to the page from where you can see the cluster usage at that time and all those information from this run page. More you will get the granular details when the job was job was run, and from that run instance you can get a lot many details. Yeah, from here it has started. Has more true. That means this is a paginated query, and you might have got only top 50 run history, right? That count you can see figure out, and it has got more records. In that case, you have to call by passing the offset and limit, right? So you can see the next set of history records for that job. Okay, so that's about jobs list and jobs run. And the last one that I want to, okay, before even that, so in this case, I'm doing the same thing, but I'm using Databricks API, not Databricks CLA, right? The purpose is same. The API construct is slightly different, and I would say this is actually easier than the Databricks CLA. That is my experience. So you can use either of them. You can do the same thing, and under the hood, it is calling the REST API. Okay. So, yeah, so that is calling the REST API. So this is just a proxy client. Okay, so we have looked at the clusters, jobs, and jobs run details. The last part in this video that I wanted to cover is the correlation between the cluster and the jobs, right? And then you can see a different view of the information, like not in separate, cluster information and job information, but correlating and combining that information. And I'll show you for each of the clusters what all jobs are run against that cluster, scheduled against that cluster, and some more details. Let's run this. Before that, I can, yeah, actually, let me run and then I'll take you through the code also. E2E, I've just used to mean end to end. So I'm going to run it, listing down the clusters, listing down the jobs, and then correlation. So that is my end to end use case. Okay, that's where it starts. I'll take you through the code in a moment. Yeah. So I'm printing from here: cluster name, cluster state, minimum nodes, maximum nodes, auto terminate after how many minutes. And then there are 20 clusters that we have seen. So for each of the cluster, you get these details. Cluster name, in this case, again, it is obfuscated. When you will run, you will see the real cluster name that is existing in your Databricks workspace. The current state is terminated. I missed one column here. This is like the SKU type, right? In this case, it is standard D8S V3. And then minimum number of nodes, worker nodes is 1 for this cluster, maximum is 20, auto terminate after 10 minutes. For the first cluster, you can see there are 3 jobs which are scheduled. It goes by which user has scheduled, what is the current status of the job, is it paused, is it unpaused, is it scheduled. In this case, you don't see it, so this is not even scheduled, but otherwise you'll see most of the cases it will be paused or unpaused. What is the schedule? Because it is scheduled already, that's why you'll have paused or unpaused. In that case, you'll have a schedule. Now, if you see the cron expression, that will be very cryptic. So I have used something that is human readable using the cron descriptor that I mentioned earlier. Right? So this is converting that cron expression into human readable format at 9 a.m., which means this is running every day. And it's going to use UI cluster. It's not a job cluster. And the job name is job underscore 19. And this is obfuscated. In your case, you will see the real job name, right? Let's take one more example. So these are all UI clusters. That means this is a persistent cluster. If you go now to the Databricks workspace page, you will see this cluster present under the clusters page. This cluster has a different configuration, like 8 worker nodes minimum and maximum 32. And it has got 60 auto terminate after 60 minutes. That's too long. Right? I would highly recommend in such cases, you should rather schedule, as minimum as possible, like 10 minutes for majority of the cluster would suffice. So yeah, that's how the information is represented here. Again, this is in terminal. It is not as visual as it could be, right? We can make it much more intuitive. I'll probably cover that in some upcoming session where I plan to push this information into a CSV set of CSV files or database tables, and from there I'll create some dashboards using Apache Superset. This is what I wanted to cover in today's session. So you see, the objectives were listing down all the clusters that we have done, listing down all the jobs, and then finally correlating these two information, like which clusters is running what all jobs and what is the current status of each of the jobs in that cluster. Now, why it is important is sometimes this auto termination, this is something that you want to optimize. You don't want to unnecessarily keep your cluster running idle for so long. So by looking at this visually across all the clusters, it becomes very, very prominent. Like what are the things that you want to optimize. Here you can see some of the clusters. Although it is not running any job, that is another point. Okay, if this cluster is not running or attached with any other jobs, then why do you want to keep that cluster in the system? What is the purpose? uh, and then the auto termination minute is again set as 60. Coming back to the previous point that I wanted to cover is the other optimization that I want to look at is, at some point if you have scheduled too many jobs at the same time in the same cluster, that means the overall configuration for that cluster that is required is going to be much higher than otherwise if you have would have scheduled all the jobs at a different time slot, where the compute need that is required at any point is only coming from that specific job, not the collective requirement from multiple jobs if you have scheduled them at the same time. That is another optimization that you can do. So these are some of the things that you can achieve out of this exercise. Thanks for watching.